Today talking about microplastic pollution. So I am a bit unique as a University of Illinois Extension employee. So I work for Illinois Extension, but I am one of a few folks within Extension who works for Illinois Indiana Sea Grant. And it's one of 34 programs across the country in every coastal state, including the Great Lakes. And we focus on building sustainable, resilient coastlines. So much of what I'm going to talk about today is really applicable to any body of water, any type of pollution, but I will touch on some Great Lakes specific things because that's what a lot of my work focuses on. Okay, so I'm going to kind of start big picture and then narrow it down a little bit. So I'll start by sort of giving a brief overview of what we consider to be contaminants of emerging concern, or CECs, or emerging contaminants, and then talk about plastics in general, and then we'll get down to microplastics. So we'll kind of make our way through that as we go. And then hopefully, even though most of what I talk about will probably spin towards the negative a little bit, we'll wrap up with some sort of tangible things and ways that you can help with this problem sort of in your own daily lives. So contaminants of emerging concern have an official US EPA definition, so the Environmental Protection Agency. And these are things that are detected at low levels in surface water. There's concern about impacts to aquatic life. There's no regulation of these materials.
Just says it's not working.
And
worked yesterday.
They were
Why is it
recently
so small?
discovered due to improvements in either analysis or detection. So they could have been there all along, but we've just recently found them because we are getting better at finding these things. There's a bunch of different things that fall into this category, contaminants of emerging concern. It includes things like persistent organic pollutants, which are flame retardants, and things like PFAS, which you may have heard about in the news recently. Things like pharmaceuticals and personal care products, endocrine disruptors like BPA, which is that chemical that hardens plastic that was recently removed, is being recently removed from water bottles and plastic cups and plates and things like that. Nanomaterials like nanotubes or titanium dioxide, like from sunscreen, so very, very small things. And then microplastics and what we call anthropogenic debris, which is just a really, really fancy way of saying garbage from people. So I want to kind of start first with a little bit of a reflection. So I'm going to ask sort of three questions. No need to think too hard about this, just what comes to mind. So what's the most common thing that you think is in the trash at your home? Is it food scraps? Is it paper? Is it maybe plastic? Are single-use plastics a part of your daily life? Do you buy bottled water or pop in bottles? Do you use disposable silverware? Things like that. And how much trash in pounds do you think that you generate every day? And I like to think of this as a gallon of milk weighs 9 pounds. So everybody kind of knows what a gallon of milk feels like. So how much trash do you think that you generate every day? And the answer might actually surprise you. So every person in the United States generates nearly 5 pounds of waste per day. In 2018, that amounted to 292.4 million tons of trash. And I should mention, this is data from 2018 that was released in 2020. This is from the US EPA. They started releasing 2019 data in 2023, but they haven't updated the next few graphics that I'm about to show you yet. So I'm looking forward to seeing more updated information on this. But yeah, so about a half a gallon of milk, that's the weight of the garbage that each one of us generates every day. About half of that garbage goes to the landfills. 32% of it is recycled, and nearly 12% of it is burned. So that's how we're getting rid of things. So hundreds of millions of tons of garbage is being landfilled and recycled. The problem with recycling as good as it is that the pace of recycling has not kept up with how much plastic we've generated. Um, Over the last 50 years, you can see here that in red, we have the generation of plastics, and it is just on an upward trend. And then the trends of recycling and how much plastic we're able to recycle, it has increased since the 90s. If folks remember back in the 90s, when we all started recycling, I remember that all the waste companies started delivering little recycling bins, and we were all so excited, and we had to separate everything, and that was the mid 90s. And so that's when you can start to see that uptick. But in no way has recycling kept up with how much plastic were generated. And that's because plastics are really integrated into our way of life. Okay, the first plastic was introduced in the early 1900s in 1909. In 1946, Tupperware, the most famous plastic, was invented. And as a result of that, and the sort of single-use plastics boom, we can see in this Life magazine cover, by 1955, plastics were really well integrated into our way of life. So this is a cover from 1955 talking about how wonderful throwaway plastics are for cutting down on household chores, on the work that we're doing in our homes. And there's no denying the fact that it has done that. It has made many people's lives much, much easier. But it does come at a cost, we've learned. In 1962, plastic bags were invented. And by 1977, they were replacing paper bags in stores, primarily in grocery stores. That was sort of the biggest group of stores that adopted using these plastic bags. And by 1976, shortly before plastic bags were introduced into grocery stores, plastic was the world's most used material. So again, it is really well integrated into our lifestyles. Disposability is really a way of life. And we resolved a lot of challenges with that, but we also created our biggest challenge, which is all of this waste and the impacts that it has on the environment and on us. So back in 2017, this research team undertook a project to figure out the production, use, as the title says, production, use, and fate of all plastics ever made. And they came up with some really interesting results. And so this is a graphic from that paper. And what I really want to call your attention to is up in the corner, you can see 8,300 million metric tons have been produced. And of that, you can see the blue arrow on the bottom, about 7%, 600 million metric tons is recycled. The gray area arrow going to the side, 700 metric tons or 8% are incinerated. And then we have 55% or 4,600 is being discarded, and the rest is still in use. And so this is a literal ton of plastic. This is a huge amount of plastic, but there's one really important thing that I want you to note here. And that is that what this graphic tells me is that 92% of the plastic that was ever produced still exists, because the only way to truly get rid of plastic is to incinerate it. Incinerating it breaks it down into, the chemical compounds. Recycling it doesn't do that. Putting it in the trash doesn't do that. So 92% of the plastic that we have made is still somewhere on Earth, whether that's in a landfill, whether it's been turned into another plastic, but it's still there. And of all this plastic, 20 million tons of this plastic every year enters our waters. And that's sort of where we're going to focus the rest of our energies today. So the garbage that ends up in the water ends up in a few different places. It has what we call several fates. And the first is that it accumulates. It ends up in the water, it ends up in the beaches, and it just sort of gathers. And that's sort of the most frequently discussed when you talk about garbage in the ocean. Many of you may have heard of the Great Garbage Patch. There's multiple garbage patches out in the oceans. So many people have heard of that, and that's sort of thanks to the accumulation of garbage. Ingestion is also another big one, right? We know, and we hear in the news on really a regular basis that aquatic life eats plastic, and often they die with a large quantity of plastic in their stomachs. And most important for our purposes today is these plastics can also break down. They can decompose to a certain extent, but really we're talking about plastics that are breaking down into smaller and smaller and smaller pieces. So in terms of microplastics, there are a number of different types, but they all share sort of the one key characteristic, and that is that they're less than 5 millimeters in size. So a half of a centimeter. They're very, very small pieces of plastic. There's two different types of microplastics, primary and secondary. Primary microplastics are those that are made in the form that they are found in. So they are made small. Production pellets, or they're also called nurdles, are sort of the biggest of the primary microplastics. These are tiny little plastic pieces that get molded into larger pieces. I like to say, if anyone has ever done a mold-orama at the zoo or anything like that, I actually have one right here. So this is a mold-orama. I put money in the machine and it heats up nurdles and it melts them into whatever shape I chose. This happens to be an eagle. Microbeads are another type of primary microplastic. These are found less often in our products that we purchase now, but for a long time, microbeads were a huge, huge addition in personal care products, right? The scrubbers in the scrubs that we use and things like that. And as a result, there are billions of microbeads out in the water. They have been banned at the federal level from being in our personal care products. And so we're not producing more microbeads at that scale, but the ones that exist are still out there. Then you have secondary microplastics. These are microplastics that were created by breaking off of larger plastics. So they're small pieces of a larger plastic. So little shreds of water bottles that break down, or plastic film. They are often the result of like weathering of larger plastics. Beach cleanups attempt to pick up a lot of the garbage that turns into this type of secondary microplastics. Foam is another one I should mention too, like large styrofoam coolers. If you break those in half, you get a lot of little tiny little pieces. Those are another type of secondary microplastic. And then there's also synthetic fibers. These are pieces of fiber plastic that comes off of textiles. So it's coming from clothing, carpets, any sort of situation where garments are rubbing against one another, or you're agitating these fibers like in a washing machine. You could be shedding synthetic fibers if your clothes are not made of a natural material. So this is what these look like in practice, for real. So if you can imagine, this is a Petri dish. It's about 3.5, maybe 4 inches in diameter. And then there's this filter paper in the middle. And that filter paper blown up is what you see in this large image on the screen. And so this is what these look like. You can see a large blue fragment, a small piece of styrofoam, a nice blue fiber right here, and then a microbead, probably a nurdle, which is a pellet over here. So these things are very, very, very small. In many cases, in particular in the case of fibers, these are essentially invisible to the naked eye. So we know and have known for a very long time that microplastic is everywhere in marine systems. And I'm just going to kind of go through this timeline and highlight just a couple things on it. We're not going to go over this whole thing because that would bore you all to tears. So in 1973, there was a paper that was published where marine pollution was found to cause considerable harm. So we already knew that pollution I didn't realize that I was giving myself applause there. we knew in the 70s that this was a problem, that marine pollution was a problem. In 1982, we knew that plastic was bad for marine birds. We knew that they were eating this plastic, right? So it's been 40 years now that we've known that this was an issue. In 1987, we found that the major inputs of plastic debris and debris that is found in the ocean actually comes from land. So it's things that are washing from land into the ocean. It's things that are being transported across the ocean from one land to another that are ending up in the water. It's things like that that are causing these problems. They aren't being generated in the water. By 1999, research was finding that plastic was outweighing plankton, or the tiny animals in the oceans, by 6-1. And in 2010, we knew that fish were eating plastic. The North Pacific gyre is one of the garbage patches. And so research out there, they went out, caught some fish, dissected them, found plastic in their stomachs. And by 2016, the United Nations estimated that there were 5.25 trillion pieces of plastic in the ocean, both macro and micro. And I can't even fathom what 5 trillion pieces of plastic looks like. But what we know now, and what we've known since probably the early 2000s, is that it's not just the oceans. For many, many years, fresh waters were neglected. And we worried about the oceans, rightfully so, but we didn't look to our backyards, right? At least us here in Illinois, right? We didn't look to the Great Lakes. We weren't looking at our rivers and our streams and our inland lakes. And we know now that microplastic is everywhere. It's in all ecosystems. It's on land. It's in all kinds of bodies of water, not just the ocean. Now, the first study that looked at the Great Lakes, and here's where I'm going to get a little Great Lakes specific for a few minutes. The first study that looked at the Great Lakes went out and sampled in Lakes Superior, Huron, and Erie only. They skipped Lake Michigan, which is our Great Lake here in Illinois. But you can see that they found a lot of plastic, right? The larger the circle, the more plastic they found. And in particular, near some of these hubs, particularly Buffalo, offshore of Cleveland, downstream of Detroit, things like that, they were finding, large pieces of plastic. A few years later, a group of researchers funded by Illinois Indiana Sea Grant went out and sampled Lake Michigan. Same story, lots of plastic everywhere they looked. A lot of concentrations near harbors and places where people were, right? Which makes sense, especially if things are washing off into the water. This makes a lot of sense. And really at this time, the big news item was microbeads. They'd found microbeads. They were talking about microbeads. Illinois was one of the first states to actually start to ban microbeads, which is wonderful. But the federal government really jumped on it right away, and they banned it shortly thereafter. But really, that's what everybody thought that they were going to find. But that's not the story, especially in Lake Michigan. That's not the story. And it's interesting because this first study that looked at the first 3 lakes, Superior, Huron, and Erie, found primarily fragments. You can see under fragment, 42% fragment, 48% pellet. So pellet microplastics, or microbeads, I'm sorry, microbeads. And then no fibers, which is line here, a little bit of film, and a little bit of foam. When our study went out into Lake Michigan, this completely changed. The amount of microbeads that were found in this study was significantly smaller. And instead, we found a lot more fibers. And this kind of started the dialogue about microfibers in our water. And I can give credit to this research team that was Illinois Indiana Sea Grant affiliated, because I myself was not affiliated with it at the time. So I'm not patting myself on the back, I'm patting some former colleagues on the back, because they did really great work and it caught on and became newsworthy across the country. But there was a lot we didn't know, right? Clearly, that's illustrated if you think you're going to go out and you're just going to find a ton of microplastics and tiny little fragments of plastic, but you're finding all of these fibers. It raised a lot of questions. And we realized that there were a lot of questions about microplastics that we didn't have any answers for. And this is in the early 2010s. For one, Are all these studies sampling water the same? Are they finding these plastics using the same equipment? Are they using nets that have the same size mesh? Or is one of them allowing all the small things to go through and another one trapping all the small things? There were no standard methods for sampling microplastics. And so as a result, it was really hard to compare apples and apples. But most importantly, there wasn't a lot of information about what the effects of microplastics were, not just long term, but also on the health of organisms and on the health of us. How does this impact people? A couple of years ago, there was a feature in Nature magazine that was really popular. Microplastics are everywhere, but are they harmful? This was 10 years, 15 years, 40 years after we knew about microplastics. We're still asking these questions. We know they're everywhere. We know they're in things, but are they harmful? Still is a question that we're trying to get answers from. And that's sort of what I'm going to talk about next. So we know that there are impacts, what we call toxicological impacts, right? So these are sort of the chemical impacts that microplastics can have in the environment. The biggest thing here is that plastic itself can both leach chemicals out into the environment and chemicals can absorb onto plastic. And so these plastic particles then become sources of other types of contamination, right? Other types of toxic chemicals can be released and bind onto these plastics. And so it can move them around and move them up into the food chain. And different plastics have different risks where that comes in. So there's some research on marine plastics that showed that certain types of plastic really absorbed toxic chemicals a lot better than others, which is important when you're deciding sort of what materials you want to buy and use. We also know that there are impacts on the ecology of organisms. We know that animals eat plastics. In this top picture, you can see this is just a zooplankton, and the bright green inside of it is plastic. This picture of the fish, the dissected fish, and the plastic that has come out of it, that's one of the fish that was caught in the North Pacific Gyre when we figured out that fish were eating this plastic. So there's been a lot of studies that have shown a real wide variety of impacts on organisms. How bad those impacts are is still sort of one of the outstanding questions. But we know that certain organisms have decreased reproductive success, and as a result, they have decreased survival. We know that predators are eating prey, and when they eat prey with plastics in them, they also eat the plastics. And plastics may be changing ecological communities as a result of that. So some folks at Illinois Indiana Sea Grant decided, and this was at Purdue, funded by Purdue University, they decided to systematically take a look at a lot of the studies that had been published, looking at the impacts of microplastics on aquatic organisms to see if they could tease out any patterns. And they did this using what's called a meta-analysis. And this is really just a fancy way of saying that they did a study on a bunch of different studies. So they took data from existing studies and tried to assess the effects of exposure to microplastics on it. And the way they did this is a little bit over my head. So this really all you need to know is that they were looking at already published data and trying to figure out the patterns among all of this data collectively. So they looked at 43 different published studies, and there was pretty significant and rigorous criteria that these studies had to follow in order to be included. They had to measure effects of microplastics exposure on an organism. It has to have been an experiment, not something where you just go out and sample a bunch of organisms and see what's in them. It had to include a control where there were no microplastics, and it had to report specific types of data in order to compare them. And the one most, I think, important thing about this is that this meta-analysis accounted for what we call publication bias. And this is a term that was sort of invented through research in the medical community, but essentially what it is the tendency of researchers to publish research that only has significant results. or the tendency of publishers to only accept research that has significant results. One of the things as a scientist that you learn is that a result that's not significant is still a result and it still counts. Just because your result doesn't come up with a negative effect doesn't mean that that's not important, right? Maybe no negative effects is the important result. So they wanted to account for the fact that a lot of these studies that they were looking at, the group of studies that they were looking at might be missing some key pieces because important research that could have contributed to it may not have made it into the publishing. So they were able to mathematically account for that. So the question they asked was, for aquatic organisms, what is the impact of exposure? And they looked at 4 different categories. They looked at consumption and feeding, growth, reproduction, and survival rates. And here's what they found. And there's no need to really take all of this in. There's just a couple things I want to point out. So if you look at the pluses, the stars, it's significant negative effects, and the pluses is possible negative effects. And it's really the significant negative effects that were most important. And so I want to call your attention to the zooplankton line. So zooplankton, these are the smallest animals in our waters. These are the base of the food chain. So this paper found significant negative effects on growth, on reproduction, and on survival of zooplankton, which again, the base of the food chain. So what does that mean? Well, it's not really a slam dunk because we're only looking at 43 different studies, and that may sound like a lot, but it's really not. But it tells us that we think that zooplankton are really maybe more susceptible to microplastics exposure than some other groups. And many people then, the next question they ask is, why should I care about zooplankton, these tiny little animals? Well, let me show you. This is the food web in Lake Michigan. So if you start at the top, that's all your big predatory fish. Lake trout, Chinook and coho salmon, bass, the trout, walleye. These are the important fish that we've built multi-million-dollar industries on fishing, right? There's a lot of money involved in sport fishing on the Great Lakes and in Lake Michigan. But there's a trickle-down effect, or rather a trickle-up effect. If you go to the bottom, this is where you see phytoplankton. The very bottom is phytoplankton. These are the tiny plants. The tiny plants feed the tiny animals. We have native water fleas, calanoids, cyclopods, water fleas, possum shrimp, amphipods. Those are zooplankton, tiny animals. Those feed smaller fish, rainbow smelt, deepwater sculpins, yellow perch, alewife. Those in turn feed those big fish that bring in big dollars into communities along the coast of the Great Lakes and anywhere really that has these types of sport fishing. So there's a cascade effect. The smallest animals have a really big impact up front, because if we're seeing reduced growth and reduced survival of zooplankton, that means there's not enough food for the prey fish. If there's not enough food for the prey fish, their numbers are going to decline. And if the prey fish numbers decline and there's not enough food to feed the large sport fish, then those numbers are going to decline as well. So all of these things are really, really interconnected. So microplastics having an impact even at the very base of that food chain can be felt way up at the top, and can even be felt sort of by us in terms of the economic impacts of these things. What we're really, I think, most interested in is how these microplastics can affect our health. And we're starting in the past, I would say 5 years in particular, we're really starting to see a lot of research come out that has tried to answer this question. The trend in plastics research first was to find it. Where is the plastic? How's the plastic getting from one place to another? What kind of plastic is out there? Then the impacts sort of follow from that. And we're still kind of looking more at distribution in people, right? Where are we finding microplastics in people? What microplastics are we finding in people? And so then those impacts are likely to follow shortly thereafter. So this is not an exhaustive list, but what I can tell you is We have found microplastics in all different kinds of natural salts, chicken gizzards, honey, beer, tea bags, both bottled and tap water, seafood, and shellfish. A lot of different exposure routes or possible exposure routes for microplastics. Research has found that people consume about 52,000 microplastics particles per year. This was big news when it first came out because 52,000 pieces of plastic is a huge number. We have no concept of what this actually means yet, though. We've been doing this for years, likely, with no known ill effects. So I don't want you to read too much into this because this has likely been happening for some time. But it was the first time here that we really quantified how much plastic we were consuming. If you add how much we inhale from plastics that are floating around in the air, fibers are a really big culprit there. That adds another 69,000 particles of plastic per year. So we're really consuming a lot of plastic on an annual basis. And one thing I want to point out from this study is that consuming only bottled water added an additional 90,000 particles per year, as opposed to people who only drank tap water, who are only adding another 4,000 particles per year. So the bottled water industry, whether it's from the plastic bottles themselves, the bottling process, what's in the air, whether it's the water that they're using, but that process and the impact of that is a lot more, tens of thousands more microplastics potentially being consumed per year. These polypropylene bottles that we used to use for, these are for feeding babies, essentially, release a huge amount of plastics per liter, particularly when they're heated. That was another study that came out shortly after this one, showing that that plastic baby bottles are a large source of plastics. Now, looking in our bodies, research has found microplastics throughout our lungs. Fibers being the most abundant because, again, we're inhaling them. These fibers are tiny, they're light, they fly through the air really easily. And so we know that, at least for people, inhaling these fibers is a huge, huge route of exposure. And I think that's important to note, even though I'm mostly focused on what's going on in the water, microplastics is a broader category, and you can't just talk about what's going on in the water without talking about other ways of exposure as well. It's also been found in the human bloodstream. And so essentially we've found that these plastics have the ability to cross over into our bloodstream. Now, I want to point out that this study only looked at 22 people, very early stages of this type of research, but conceivably it is possible. And one of the things that we are concerned about, as I kind of mentioned before, is that these larger microplastics that we now know are in our bodies may start to exhibit effects or could potentially exhibit effects because of the chemicals that are either being released by those plastics or that have stuck to those plastics and then made their way into our bodies. So how do we fix this? There's a lot of different ways that people have suggested that we address this. And I'm going to sort of talk about this in three categories. So sort of from the consumer angle, right? Consumers and corporations and that angle, and then legislation, and then also some engineering solutions. So are the solutions to this driven by us, by the consumers, or is it totally the responsibility of corporations that are creating this plastic to take care of this? And I would say that overall, both from the larger companies and sort of even you're hearing this sort of from people like me, that personal responsibility is a really big part of this. The larger corporations would love for you to believe that you switching from plastic straws to a paper straw is going to fix this problem. They would love for you to believe that, and that is simply not true. The scale of plastic production at these large corporate levels and the scale of plastic waste that's created, you and I changing straws is not going to fix all of this. But personal responsibility is really important. And if you make a decision to give up plastic straws, then maybe you make a decision to give up something else when that becomes easy and something else. And maybe it has that sort of trickle down effect. And the more people that do that, the more plastic is prevented from becoming a problem. But research has found that really there's only about 20 firms that produce about half of the world's plastic. And of that, I think Coca-Cola, PepsiCo, those are the real big heavy hitters. And I think that is probably, that probably makes a lot of sense to most people. So we can't legislate plastic away, but the legislation can help spur people into action. Many legislative solutions can be accomplished on a personal level first. Straw bans have been effective at reducing the amount of plastic straw waste. Plastic straws are a big problem in beach cleanups and things like that, no doubt. And so removing those altogether just takes that out of the equation, and that's not a bad thing. Similarly, plastic bags, we've seen those banned in certain areas, but then we've also seen in some states in the Great Lakes anyway, we have bans on bans, right? They have been preventing at the state level, they have prevented smaller municipalities from banning those bags. We've seen single-use plastic bans. In New York, they have a statewide ban on styrofoam, like clamshell containers and things like that. That's for a lot of like takeout packaging and things like that. And at the federal level, a new bill that's being discussed is the Break Free from Plastic Pollution Act. And it's incredibly ambitious, and I have no idea if it's actually going to go anywhere. But it is intended to hold those large polluters responsible for reducing the amount of plastic that they put out into the environment. And so it could really do a lot of good. So one of the other ways I think that you can sort of personally use your personal responsibility to address this through legislative solutions is by supporting this legislation as well, right? Support the legislation, let your elected officials know that it's important to you to reduce plastic waste. Then there's engineering solutions, and I think these ones are really interesting. In particular, I'm going to talk about engineering solutions for fibers. Fibers in the laundry is a huge, huge issue. Just hundreds of thousands, millions of fibers are released in laundry wastewater on a regular basis. And wastewater treatment plants are not necessarily designed to capture all of those fibers, although they are very effective at it. When you're talking about millions of fibers, even if they're catching, 95% of it, which some of them are, that's still a lot of fibers that's making its way out into natural waters. So trying to figure out a way to catch those fibers before they end up in the water, get them into the waste stream and landfill them instead, where they can maybe be, contained. There's a real push for that. And so the three things I want to touch on are the Guppy Friend, which is a washing bag. And these are pretty effective. You put I'll use a fleece, for example, here, because fleece are notorious shedders of plastic fibers. You put your clothing items into the washing bag and then throw it into your washing machine, not unlike a delicates bag that you might use for lingerie or putting socks in so they don't get lost. And it does two things. One, it cuts down on the friction of the fabrics that releases the fibers. And it also traps those fibers so that you can clean them out from the seams and then dispose of them properly. I would say that a cotton pillowcase could also be somewhat effective. I've never seen any research on this, but in terms of stopping the friction, a cotton pillowcase might be just as efficient in reducing fibers as well. Then there's a product on the market called the Cora ball. And this is a ball, it's about the size of a softball, kind of looks like a koosh ball, if some of you are familiar with those, either from your childhood or your kids. And the idea is that it goes into the washing machine and it captures fibers. The fibers get trapped on all of the little nooks and crannies, and then you can kind of clean it out. And I actually have one of these, and it works. It collects fibers. And then probably most effective here is a filter. Just like you put a filter on your tap to capture impurities in your drinking water, this filter filters out fibers from your wastewater before it goes into the waste stream. And the fibers are captured in that tube, and then you just clean them out. The issue here is we're talking about installation and a product that costs more, upwards of, in the hundreds of dollars rather than something that costs, in the tens of dollars. But there has been research evaluating these, and a paper in 2019 found that coral balls reduced microfibers in washing by 26% by count. And the lint lover, this filter that can be installed, reduced them by 87%. So really can be really highly effective. There's another study that came out in 2020 that evaluated even more options. The percentages differed, but the point here is that all of these options effectively captured or prevented the release of microfibers. So people are getting really clever and coming up with ways to prevent this pollution from even ending up in the water. So I promised sort of a solutions-focused end to what we were going to talk about. And so first, before I sort of give you the laundry list of things that maybe you can do, I want to touch on this, what is the 5 R's. So I kind of talked early on about, the mid-90s when recycling became really popular and everybody was talking about the 3 R's, right? Reuse, reduce, recycle. We now know that more is needed than just those things, right? So the base of the new R's pyramid, now it's a pyramid, right? Now it's the 5 R's. The base of it is refuse. So now we're really trying to talk with people about not using these products in the first place. Recycling rates are not going to stay high. It's becoming more and more difficult to recycle a lot of plastics. There really isn't the market for plastics anymore, so people aren't taking them. We used to send a lot of our plastics, the United States used to send a lot of their plastics overseas for disposal, and a lot of those countries aren't taking our plastics anymore. China, I think, was one in particular that is not accepting plastics from us anymore. They have no use for them. They have plenty. So refuse has become really the biggest, best way to cut down on this type of pollution. If you can't refuse it, maybe you can reduce it using something. Maybe you can wash that plastic fork instead of throwing it in the garbage, and use it more than once, so that you're using less than you were. I may have said earlier that, or I did say earlier, that just one of us switching from plastic straws to paper straws isn't going to totally fix the problem. But if all of us are doing little things, it adds up to a lot. And that, I think, is really important to remember. Refuse, reduce, reuse things. Again, reduce and reuse are kind of integral to one another. Repurpose things, right? Find a new home for things. Don't throw out that plastic toy. Find a new home for it. And then recycling. It's still important to recycle, but recycling now is not the same as it was, 20 or 30 years ago when it first became incredibly popular to do so. So here's my laundry list of possible things that you can pick from. And I like to kind of offer this as sort of like a menu of options. And you can pick and choose any ones that might fit into your lifestyle. Maybe some of these do not fit into your lifestyle. Maybe some of these are unavoidable for you. And that is okay, right? Everybody just sort of does the best that they can. But this is sort of a variety of things that you can do and pick from, and really feel like you're making a difference. So avoiding single-use plastics and using reusables whenever possible is a big one. Avoiding plastic water bottles, not just because it creates more plastic pollution, but also because it's better for your health, I think, as well. And so using reusable water bottles, reusable containers, switching from glass or from plastic to glass sort of Tupperwares is great. I know it's not always feasible, particularly when you're packing stuff for your kids. I know we tried to make a switch, and then we had a new baby and he is a terror, and we had to put them all up and away. Because the glass ones became a real hazard when my tornado son ends up in the kitchen. So, but figuring out what works best for your lifestyle is really important when it comes to this. Choosing natural fibers whenever you can is another way. All of our carpets generally are made out of plastic. Rugs, polypropylene, plastic. But now you're finding that there are more natural fiber options. Oftentimes they are more expensive. Oftentimes, a lot of these things that I'm going to tell you may cost money. And that I think is important to keep in mind as well, that there is a cost associated with a lot of these things. But tap water's free. You don't have to buy a fancy water bottle. But maybe you can't choose a wool rug because it's more expensive. Maybe you can't recarpet your home in wool or hardwood, and you just have to deal with the carpets that you have. That's okay. That's fine. But being aware that those are non-natural fibers and that plastic fibers may being shed from these things is important to keep in mind. Okay, choosing tap water, filtering your tap water. Filtering your tap water, like through a Brita filter or something like that, does remove some fibers too. So if you choose tap water, you're already getting fewer fibers than you would if you were drinking bottled water. And if you filter it, it's even fewer. So tap water is by far your best choice. It's the number one thing. Drink tap water is the number one thing that I tell people when it comes to preventing microplastics from getting in you, and also from sort of creating more microplastics or supporting an economy that creates more microplastics, right? If fewer and fewer of us drink bottled water, maybe bottled water won't be as popular or as common. Taking steps to reduce laundry fibers when you can. Fleece, this is Illinois, right? We have horrible springs, horrible winters, and most of fall is very cold too. We all wear fleece. And so I don't think anybody's going to give up their fleece. I'm not going to give up my fleece, but I don't wash my fleece as often as I used to. Newer fleeces are tighter and shed fewer fibers. So I spot clean my fleece whenever I can, because the more it goes in the washing machine, the looser those fibers get and the more can be shed. So even just doing less laundry, right? Not washing things that are made from rayon or polyester or microfiber. Washing those things less is a great solution. Consuming seafood carefully is important too. There's a lot of microplastic pollution in seafood. So keeping an eye on how much seafood you're consuming, I think is important. In particular, shellfish. Shellfish has been found to have pretty high amounts of microplastic in it, as opposed to like fish fillets and things like that. Dusting and vacuuming regularly is another big one that I think a lot of people don't think about. But if you're dusting and you're vacuuming and you're disposing like of what you vacuum up in the trash, you're removing loose fibers as you do that. And so you're removing the ability for those fibers to get kicked up into the air and then enter into your lungs. So dusting and vacuuming regularly is actually really important. And then the last thing, and I mentioned this already, is supporting policies that limit single-use plastics and supporting policies that hold these polluters responsible, right? Let's get Coca-Cola to pay for more of this, not just paying for more beach cleanups, but let's get them to just reduce how much plastic they're using. And I think even if that's just the one thing that you could do, is send an email to your legislator when you hear about these things. If that's all you can do, you're doing a lot, and you're doing something that's really, really helpful. So hopefully one of these things speaks to you, and you can, incorporate it into your daily lives if you're not already, or maybe you can add something else. Or if anything, maybe I just convinced you that tap water is fantastic, and I'll take that. But yeah, so that's what I wanted to leave you with. And with that, I'm happy to take any questions.
Thank you so much, Sarah. That was so illuminating and really well put out throughout the entire presentation. We have a few questions. One of them was asked early on, and I know you're with Sea Grant, kind of like affiliated with U of I, but so if you were aware of any ways in which, like any initiatives that the university is doing to kind of like do something about the plastic pollution problem, things like that. Is there anything that you know of? And that's okay if not, because I know like you're not necessarily on
Yeah,
campus as
I'm
often.
not on campus, but I feel like I did hear, I know, I guess I can't speak to the University of Illinois. And but I do know, at least in my extension office, they used to provide bottled water and they switched to, because the water isn't the pipes are very old, and they switched to a service that brings like the larger jugs, which again, it's not ideal, but is better. And I don't know if that's something that happened extension wide. But yeah, I'm not aware of anything that's happened on the U of I campus, but I do know that universities in general, there's a huge push for more sustainable options in dining halls and coffee shops and things like that. The college students in particular are very vocal about that, and they really are committed, I think, to more sustainable ways of life. So I think in general, there are likely things going on. I'm just not aware of them. It's a great
Yeah,
question, though.
Yeah, I wonder if the Illinois, the Institute for Sustainability, Energy, and Environment, IC,
Yeah,
has some things on their website that might be more illuminating for that person if that's
that
helpful.
actually that makes me think. So I do know one thing that IC does is they certify on-campus events as green events. And I host a emerging contaminants conference, and some years it's on campus. And we certify ourselves. It's a self-certification process, but you pick from a list of sustainable activities. And not offering single-use plastics is one of the initiatives on there, and that's one that we do every year. We offer real silverware and glassware for people, and we don't offer bottled water, things like that. And so that helps us become a green event. So I'm sure there's something on IC's website mentioning that.
Yeah, in fact, I think in 23 and 22, I'm not sure what the state was for 24, but we were also a certified green event, the Everyday Environment webinars. So because it was
Excellent.
offering virtual versus in person is another
Yeah.
way to kind of reduce emissions and things like that.
Yeah.
Awesome.
Yeah, absolutely. Yeah, we've been able to certify even when the conference is virtual. We still say that we're certified, even though it's very easy to certify a virtual conference.
True. So somebody was just wondering about, water filters, filtering out microplastics. You answered that a little bit. Is recycled plastic used to produce composite lumber? If so, is there a downside to this?
Yes, it is. And is there a downside to this? Maybe. So I think one of the things that it's important to keep in mind with recycling in particular is that whatever plastic you're recycling, you're not, if it's being turned into something else, it's turned into a lesser product. So if you're recycling a water bottle, it's not going to make water bottles again. It's going to make something that's a little bit less strong or requires, a little bit more work to create. It's really downcycling, we call it, rather than recycling, because we're not just re-upping these bottles, right? Like it's not like glass returnable pop bottles where they get sanitized and refilled. They get broken down and remolded into things, and they don't have the structural integrity to make what they used to be. So they end up as something smaller. In a lot of ways, that's okay. Because I think things like composite lumber and decking and things like that are a great way for some of these lesser plastics to really get compressed into a product that's useful. They do wear, right? And I know I've seen like old composite decks where you can see that, like, I don't know, the plastic kind of threads a little bit. But is that better than those plastics going to a landfill? Absolutely. I wouldn't steer people away from that. Another way I know they're reusing plastics and things like that is in road surfaces. That one has me a little bit more nervous because roads are made to wear down. And so I'm not a huge fan of that. But composite lumber, composite decking, I think is probably a very good use for recycled plastics. I don't think it's all made from recycled. I think you would have to check the particular one that you're looking at, but I know some made from recycled plastics.
Nice. So the Cora ball can be about like $40 or more. Is there a
Mhm.
similar product that is less expensive?
I wish there isn't. And I think personally, taking off my Sea Grant hat and putting on my everyday consumer hat, they're ridiculously expensive. Um, and they're actually, they used to be anyway, kind of hard to find too. Like you used to only be able to get them at like museum gift stores. I don't know if that's the case anymore. Um, but yeah, no, they are expensive. And I'm not sure if in time, as they become more popular, maybe costs will go down. But yeah, I think a lot of these things, Guppy Friend too, the washing bags, they're made by and sold by Patagonia, which is a great company, and they have a really great reputation. Um, in terms of, they recognize that, you know, Patagonia is really known for making fleeces, and they recognize that they are contributing to the problem. And so they're really committed to finding solutions to that. They're a company that I would really stand behind in terms of how they've addressed this issue. But they're not cheap either, right? I think they're $25 a bag, and it's not like you can fit it all in there. I mean, they're only like this big, right? They're maybe a half the size of a standard pillowcase. And so cost is a barrier on a lot of these things, and that's really unfortunate. And hopefully with time and, you know, more engineering and a crop of new engineers, right, that are in university, in high school, growing up in this world where we're all talking about this now, hopefully we'll see, you know, bright things from this younger generation in the future.
Awesome. Are plastic bags, i.e. Ziplocs, also adding to this problem?
Yeah. Unfortunately they are. And those are a trickier one, right? Like, I think it's really easy to refuse a plastic grocery bag. You can bring your own bag. You can carry your items. You know, if you go to a big box store, you know, you can use a box instead of bags. But Ziploc bags, you know, if you've got kids in particular, they're kind of a necessity. And so there are a lot of products on the market now that are reusable zip top bags. They're typically made from silicone, so they're fairly easy to clean, but they're really kind of inconvenient. I use them for my daughter's lunch, and the worst part about her coming home from school is that I have to wash her reusable bags or reusable Ziplocs when she comes home, because especially when she has a peanut butter and jelly sandwich, because they get really messy. But again, those are products that you have to purchase. So, you know, that's kind of unfortunate. You can also buy, I have seen Ziploc, these are only for sandwich bags, right? For school lunches, really, but they are paper bags that are the size of sandwich bags. And I think that's really great. So, and for Ziplocs, you know, I think maybe one of the, you know, in looking at those 5 Rs, you know, I think that reusing and repurposing might be really important here. You know, can you wash out or rinse out those bags and reuse them? If so, get as much life out of them as you can before putting it away. And I think if things are responsibly disposed of in a landfill and they don't become, you know, beach litter or things like that, you know, then you're also being responsible when it comes to that. You know, it's, you know, don't open up a package of, or don't open up a candy bar and throw the wrapper on the ground. You know, those are the things that we're really worried about, more so than what's happening, you know, going into your household garbage.
Well, it is 2 o'clock, Sarah, but I have a couple of other questions.
Sure.
What are you thinking? Do you want to,
Yeah, I can
send
answer.
up? Okay. Are farm-raised fish as susceptible to having microplastics?
That's a great question. And I don't have an answer for you, a good answer for you. I can speculate that they're certainly as susceptible to it. Whether they come into contact with as much is a totally different story. My instincts would say that they do not. But there's still going to be plastics in the water, you know, in the holding ponds. They're still going to have things that are settling into those holding ponds, or into those, you know, recirculating systems. So it's not going to avoid plastics, but my gut says that it's probably less. I'm going to write that down actually, and I'm going to look
Yeah.
into that. And yeah, that's a really great question.
Yeah. As far as like dishes, like cups, clothing, etc., made from recycled products, are those safe to
Mhm.
use when it comes to
Yes.
microplastics?
Yeah, absolutely. Because like what we call virgin plastic products and recycled plastic products likely are degrading at the same rate. So any plastic is um, just as safe as another. I know there have been some studies that have shown that heating plastic does make it a lot more susceptible to like shaving off and losing little pieces of plastic. So I wouldn't recommend heating things in plastic, heating glass or on ceramic, or over the stove in a stainless pan. I think that's best. But certainly using plastic cups and things like that, is not a dangerous thing.
Have there been studies to tell us if using tap water reduced microplastics in the human body?
No, not that it reduced it. Really, I think the studies that I have seen have just shown that this is the amount from tap water and this is the amount from bottled water. And so, the advice is then to avoid the bottled water. But I don't think that drinking only tap water will necessarily reduce what you're taking in, but the amount that you'll be taking in will be less than the alternative. I hope I answered that question right.
Yeah, I think so. And then when it comes to like soap, using bars of soap versus liquid soap in a pump bottle, as far as like microplastic exposure and things like
Yeah,
that. What's your
that's a really great idea. I think bar soaps and they are making bar shampoos now, things like that. Anything that you can do to avoid buying plastics that's going to end up in the trash is a great thing. A great thing. Or even if you buy liquid soap and you refill it from a larger thing of liquid soap, or you make your own hand soap. I have been known to um, make my own foaming hand soap out of Castile soap before and refill plastic containers with it. Again, I'm reusing these things multiple times. I'm getting a longer life out of them. And then when I can't use them anymore, I recycle them. So yeah, every little bit of that keeps plastic out of the waste stream in general is a good thing in terms of microplastics pollution and exposure.
got that tip myself from Sarah in a podcast she recorded a couple of years ago. So that's what I
I
do at
love
home
making my
too.
own soap.
It's
I
kind of
don't know
fun.
why.
Um,
That's as far as I go in terms of like homesteading. I make my own foaming hand soap.
that's so fun. So of the similar line of question, I just got two left. When it comes to, there's like some new laundry soaps out that come as sheets. Is that like, what are your thoughts on that as far as like
Yeah, I've
eliminating
used
plastic
those.
packaging?
I love those. Actually, so they can be more expensive. I actually found some really cheap ones on Amazon. They came in a cardboard box wrapped in plastic, which, can't really avoid that, I guess. But they came in a cardboard recyclable box, and I took them on vacation. And I went to the beach with my kids, and I did so many loads of laundry on that vacation, and those worked great. They were fantastic. I was shocked by how well they worked. So yeah, I'm a huge fan of those. And again, anytime you can avoid buying things in plastic, it's a good thing. Or buying a larger thing of laundry detergent and rather than smaller bottles, right? That's going to use less plastic over time. But yeah, those uh, laundry detergent sheets are surprisingly great. I'm a big fan.
Nice. So this one is, does the human body remove the plastics from itself over time?
That's a good question too. And I don't think I know the answer to that. I would say yes, but there's so much that we don't know. If it's in your digestive system, yes, it is. It is, for the most part, I would imagine, it is being removed through the waste stream, right? Your bodily wastes. The things that make it into your bloodstream, into your lungs, and things like that, I don't know that we know what our body does to them. But most things move and make their way out, right? Like these tiny, tiny, tiny nanoplastics that they're finding in our bloodstream are likely ending up, being attacked by white blood cells and removed in that way. But that's a great question, and I'm not sure that there's a definitive answer about that.
Yeah. Oh, we just had one more come in, and then we'll close it out.
Okay.
Just in case they missed it, using fridge filters versus Brita filtering containers. Is there like a difference? Is one better? Things like that.
No, I don't think so. In terms of the quality of water that comes out of them, I don't think there is much of a difference. They're both charcoal filters. The only thing about the Brita filters is they typically don't last as long and can't filter as much water, so they themselves then become plastic waste. But there are ways that you can recycle them. I know I used to take mine. I don't know if this is possible anymore, but I used to take mine to Whole Foods. They had a recycling. I think it was TerraCycle. It's the same way that you can recycle like applesauce pouches and toothpaste tubes and things like that. Toothbrushes, I think. But yeah, I used to be able to drop them off at Whole Foods. And I know, like, I have a fridge filter because my refrigerator happens to have filtered water, and we only have to change it twice a year. It's a bigger filter, but twice a year is not very often. But in terms of the water that comes out of them, I would say that they're equally as clean, and the filters work great either way.
Wonderful. All right. Well, that concludes our questioning.
Right.
Sarah, thank you so much for joining us. We
Sure.
really appreciate the time that you've taken to just give this really illuminating talk and leave us with a little bit of hope at the end too, and something to do about it. So I really appreciate that as well.
Yeah.
And look forward to our follow-up email about, the recording and what is expected next out of the Everyday Environment program. So thank you, everybody. Have a really wonderful rest of your day, and look forward to us in your inboxes.
Thanks for coming, everyone.